Good morning, students. I'm here with the part 3 of the chapter Integer of class 7th. Now today we are going to study about the concept of distributive property of integers, division of integers, properties of division of integers, and after going through all these, I hope you will be able to solve the problems related to the calculation of integers in a simpler way by using the properties you have learned till now, like commutative, associative, distributive, and we'll be able to do all the divisions of integers using different properties of integers. So let's see. Now before going to learn about new concept, just have a recapitulation of what we have learned so far. Integers, as you know, they are consist of whole numbers and negative numbers, and usually we denote integers with z. So -3, -2, -1, 0, 1, 2, 3, they all are integers. There is a number line you can see here. 0 is at the center and negative numbers at the left side and positive numbers are at the right side of the 0. Negative numbers are less than 0. Positive numbers are greater than 0. Whenever we add two numbers, we move towards right side in the number line. Why? Because by adding number, the value is increased. And when we subtract two numbers, two integers, we move towards left side. Because when we subtract two numbers, the value decreases. Now here you can see different properties and operations on integers in a tabled manner so that it will be easy for you. It is a compiled version of all the properties whatever you have learned so far. Here you will see that there are three colors which has some meaning. The yellow color boxes shows that these all operations of integers are satisfying for the respective properties. Pink shows that they are not satisfied and the orange one shows that this is not applicable at all. Now look at the first property, closure. Closure means closure of integers means whenever two integers are added, the sum we get is also an integer. That means integers are closed under addition. Similarly, in case of subtraction also and multiplication also. When two integers are subtracted or multiplied, the result is always an integer. Commutative property. Commutative property of addition for integer means when A is added to B or B is added to A, the sum is always equal. But in case of subtraction, this is not. A minus B is not equals to B minus A. So we can say that operations on integer of subtraction is not satisfying commutative. Similarly, in case of multiplication, the product of AB or BA is equal. So commutative property is satisfied for multiplication. Associative. When three integers are added together, whatever be the rearrangement, the sum is always equal. Whereas in subtraction, this is not so. But in multiplication again, they are equal. So, for associative, addition, multiplication are satisfactory in case of associativity. But in case of division, you see closure, commutative, associative, they all are not satisfied. Whereas in case of subtraction of integer, commutative and associative, both these cases are not applicable. The very first thing is that when commutative is not satisfied, so automatically associative is also not possible to be applicable. Now distributive, we will learn about this in this part of the presentation and about divisions also, and later on you will be very well versed in all these properties of operations on integers. So let's start. Distributive property. In case of whole number, we know that 4 multiplied with the sum of 5 and 7 is equals to the addition of the product of 4 into 5 and 4 into 7. This is called distributivity of multiplication over addition. Now let's check whether it is true for integers or not. When minus 2 is multiplied with the sum of 3 and 5, we get minus 2 into 8 equals to 16, that is minus 16. Whereas product of minus 2 and 3 when added to the product of minus 2 and 5, we get minus 6 plus minus 10, that is minus 16. Now as you can see, the product of minus 2 and the sum of 3 and 5 is equal to the product of minus 2 and 3 with the sum of the product of minus 2 and 5. That means in general we can say that for any integer a, b and c, a multiplied with the sum of b and c is equals to a into b plus a into c. Now consider the following. Can we say that 4 multiplied with 3 minus 8 is equals to 4 multiplied by 3 minus 4 multiplied by 8? Let's check. 4 multiplied by 3 minus 8 is equals to 4 multiplied by minus 5, which is minus 20. And 4 multiplied by 3 minus 4 multiplied by 8 gives 12 minus 32, which is again minus 20. So here LHS, that is left hand side, is equals to right hand side. That means in general for any three integers a, b and c, a multiplied by b minus c is equals to a multiplied by b minus a multiplied by c. As in the case before, there was the sum which was multiplied to the third integer, and here the difference of two integers is multiplied with the third, and in both the cases we see that they are equal. We have learned about so many properties, but you must be thinking that what is the use of these properties? So let's learn it with the help of this example. How these properties make our multiplication easier. Now, here we have to find the product of minus 25, 37 and 4. And I have given two ways to multiply. In the first one, we are directly multiplying minus 25 with 37, and then the product is multiplied with 4, and we are getting the answer minus 3700. But in the second, we have grouped minus 25 and 4, and then the product is multiplied with 37, and you get the answer minus 3700. Though the result is same, but you just tell me which one is easier. Obviously the second one. That gives easy solution. Why? Because multiplying minus 25 into 4 gives 100, which is easy to multiply. That is why we said that we use property here to multiply, and all commutative associative properties are used here to make the sum easier. Now see the second example. We have to find the product of minus 35 and minus 98. You can simply multiply it, but it will take time, and secondly, the chances of error are also maximum in that. But if we convert it into distributive property, the multiplication will be easier, because whenever we apply these properties, we always search a chance of getting multiples of 10, because multiples of 10 are always easy to multiply or add. As you can see here, instead of minus 98, we have written minus 100 plus 2, and then we have applied the distributive property here, and by that we have get 3500 plus minus 70, which is easy to add.
Now look at the third example. 52 into minus 8 plus 52 into 2. Now, if we have no idea about the properties, what we have done? We will first multiply 52 with 8 and then 52 with 2. It will take a lot of time. But if we apply a property here, then it will take a fraction of that. Here 52 and 52 there are common. Only difference is in the first group there is a positive 52, in the second there is a minus 52. So as per the properties of integers, whatever we have learned till now, we can change the signs. Instead of writing minus 52, we can make 2 as negative and 52 as positive. And therefore, the rearrangement will be like 52 into minus 8 plus 52 into minus 2. And the common integer will be taken outside. And minus 8 will be added to minus 2. And hence we will get minus 520. So it is more easier. That is why we learn properties, so that the use of property makes multiplication easier for us. Division of integers. Now observe the following examples. 24 divided by minus 6 gives minus 4. Here 24 is numerator and minus 6 is denominator. Numerator is positive and denominator is negative, and the quotient we get is a negative. In the second one, 24 divided by minus 4 gives minus 6. Again, numerator is positive and denominator is negative, and the quotient we get is also negative. In the right hand side examples, minus 32 is divided by 8 and it gives minus 4. Here, numerator is negative and the denominator is positive, but the quotient is again negative. Similarly, minus 32 divided by 4 gives minus 8. Same, negative numerator, positive denominator gives negative quotient. That means in integers we can say that if numerator is negative and denominator is positive, or numerator is positive or denominator is negative, the quotient will always be negative. That is, quotient is negative in case of division of a negative integer by positive integer or a positive integer by negative integer. Now see some more examples. Minus 12 divided by minus 6 gives 2. Here, the numerator is also negative and the denominator is also negative. When numerator and denominator both are negative, then the signs are cancelled out and we get a positive quotient. So here, in general, we can say that if minus a is divided by minus b, where a and b is any integer, then the quotient will be a divided by b. That is, they both will be positive because the sign will cancel out. But one thing has to be kept in mind, that denominator will never be equal to 0. So, quotient is positive in case of division of two negative integers.
Now, properties of division of integers. Look at the case here. When minus 8 is divided by minus 2, we get 8 by 2 because same sign get cancelled, and the quotient is 4. That is, we get 4 after dividing minus 8 by minus 2. Now in the second case, minus 2 is divided by minus 8 and we get 2 by 8, that is 1 by 4. Now tell me, are they same? As you can see, they both are different. When we interchange the numerator and denominator between each other, the quotient changed. In the first case it is 4, in the second case it is 1 by 4. That means in the division of integer, commutative property doesn't satisfy. Now see the other property. For any integer a by 0 is not defined. Actually, a by 0 is meaningless. Where a is any integer and 0 is at the denominator, then the whole fraction is meaningless. Whereas when 0 is at the numerator and any integer is at the denominator, then 0 by a will be equals to 0. But we have to see that the denominator, that is a, should not be equal to 0. The other property is for any integer divided by 1 gives the same integer. That is, when a divided by 1 gives a. So in other way you can say that any whole number can be written in the form of the number upon 1. It won't be a difference. It will be same whether there is any denominator or not. You can write 1 or without 1. The meaning is same. It doesn't affect the whole number. So a divided by 1 is equals to a. For example, if you say 3 or 3 by 1, they both are same. It doesn't make difference. Now next. So students, we have done with this part and this is time for assignment. I have given you a few very short answer and short answer type questions. You kindly go through it and check how much you have understood the concept. So like that, we have divided integers into 3 parts, and with those 3 parts, if you go thoroughly, you will be able to solve any kind of problem related to integers. So all depends on your practice, and that's for all. We will meet again for next chapter. So bye, all the best, and be safe.